Hello everyone, welcome to another Dungeon Mechanics tutorial series. In this tutorial, we're going to take a look at how we can use these pressure plates to make them into a puzzle, where there's a specific order that plate needs to be activated in, and only then the door will open. Without any further ado, let's get into it. Now, if you do like these videos, press the like button as it helps the channel grow and reach out to more and more developers just like you. Now I have organized our pressure plates functionality in this corner, and we're going to be populating this wall with all the new functionalities and new mechanics that we will be learning through this entire tutorial series. And I'm excited to fill this entire scene with more and more dungeon mechanics. So let's get started with this one. Let's go to our content drawer. And first thing we're going to do is we're going to create a little bit of efficiency. So to create efficiency, right now, if I go into my pressure plates, you can see that I am casting directly to my third person character. And this creates a little bit of inefficiencies in the game. So we want to eliminate that by using interfaces instead of doing a direct cast. So what I'm going to do is in my dungeon mechanics folder, I'm going to right click, go to blueprint, and then select blueprint interface. I'm going to name this BPI underscore dungeon manager. Go into this interface and then we're going to say update plates. This is the first function that we'll be calling. Right now we're casting to the character and then we're actually calling the update plates activated, but we're going to use the interface to do that update plates activated function. Now I'm going to compile and save. And in the pressure plates, I'm going to go ahead and delete the functionality that we were calling for the character, and also this cast and the reference set, I'm going to go ahead and delete it. And also this variable here, I'm going to delete it. What I'm going to do instead is I'm going to say get player character, and I'll check if this other character equals to the player character, which is the same thing as casting, but this is actually much less resource heavy. And then I'm going to do a branch and go, if this is a player character, then go ahead with the delay and continue with the function. One other thing that I'm going to do is inside of this plate movement, I'm going to change the length from 5 to 1. Instead of having this run for 5 seconds, it'll run for just 1 second. So it'll be much more quicker. And I'm going to go here and say get player character. And now we need to call in this dungeon manager function. To do that, we need to have this interface set up in our player character. So first we're going to actually call it. We're going to say update plates, and you see that it actually says a message. You need to make sure that it's actually message in bracket, or else this actual interface function will not trigger. So, and then it also has this little envelope that indicates that this is a message, and then we actually have set that up. Now, if I were to play the game, nothing's going to happen because our player character still doesn't have that interface implemented. And to implement an interface, we're going to go to our third person character blueprint, go to class settings, go to implemented interfaces, click on this add and search for dungeon. And you're going to click on dungeon manager. And if you were to open this, you will have a new function inside of it, and it's called update plates. You can right click on it and say implement event. What this will create is a new event. It also has this icon on top that tells you this is an interface event. That means whenever a message is sent and that it correlates to this event, it's going to fire. So we want to fire this update plates activated whenever this message is sent from our pressure plates. That's it for the function. Now, if I were to go ahead and press play, and I step on all the plates here, they all go down, and immediately you will notice that the open door activates right away. So now that this is functioning, and this is much more efficient than before, we're going to duplicate this to create our little puzzle. We already have the functions and the base code created, so we can just utilize this to make our puzzle. To do that, we're going to go to our content drawer, go to the dungeon mechanics, right click on here, and then say new folder and call it puzzles. And I want to use the exact same pressure plates functionality, so I'm going to drag this and drop it into my puzzles, and I'm going to say copy here. So it copies. Now I can go ahead and rename this and then BP underscore puzzle plate, and now I can press save. Okay, and I'm going to drag this puzzle plate and I'm going to put it right here. Let's move this down a little bit, and then I'm going to also copy this and paste it here. So now I can name this to puzzle plates. Now let's open the puzzle plate and we need to do something very important. We need to give these puzzle plate an individual ID. So we're going to create a new variable and name it plate ID and make it of the type integer. We're going to make it expose on spawn and instance editable. What this allows us to do is in the game, I can move this puzzle plate and here I have a new default function called plate ID. I can set this to plate ID 0. I can press Alt and then drag this and then make this plate ID number 1. Alt, Alt and then drag this and then make this plate ID number 2. And this would be plate ID number 3. So now I have 4 plates. Now you can choose to add as many plates as you would like to make this puzzle. For the purpose of this tutorial, we're going to keep it nice and simple with 4 plates. Inside of the viewport, we want to add the plate ID to be visual so the player knows which plate number belongs to which plate. To do that, I'm going to click on the plate and click on add and search for text. And you will get an option for text render. Select this text render, bring it up a little. X scale, set this to 5. And the Y scale, set this to 15. And then let's go ahead and the horizontal alignment, set it to center. And the vertical alignment, set it to center. In our construction script, we're going to grab our plate ID. And we're going to drag this text render in here and say text, set text. And the set text would be this. And then drag it in here and compile. What this will do is it will add that 0 or whichever the plate ID is onto the actual plate. I'm going to select the text render and then on the X scale, I'm going to make this into a 8. Oh, sorry. Keep that 5 and this one into a 20, just so that it's a little bit taller. Okay, so you see plate 1, 2, 3, and we copied and pasted the plates, so now we have the functionality. The plate's going underneath the ground. It doesn't really matter because we still see the number and it does show us the plate is activating. We want to move on to our next function. The next functionality that we want to do is if the puzzle is incorrect, we want to be able to reset this puzzle. So for that, we're going to create a custom function. I'm going to call it reset. For that, we're going to create a custom function, a custom event, and we're going to call it reset plate. In this reset plate, we're going to copy and paste some functions from up here because it's the exact same functionality, but it's just going to be doing it in the opposite direction. So I'm going to copy this entire timeline function and setting the world and also getting the axis, and I'm going to copy it and I'm going to paste it down here. And drag this reset plate and I'm going to say play from start. And inside of the timeline, I'm going to select it and then select this dot and I'm going to say instead of -10, I'm going to make it 10. Compile, save. So now instead of from the bottom, it's going to go back to its original position. And also, we want to make it so that once the player steps on the plate, we want to disable the trigger so the player doesn't have the opportunity to keep stepping on the plate again and again, right? So we're going to create a Boolean for that to manage it. So we're going to call it B is trigger active and make it a type Boolean. And we're going to drag this functionality a little bit over and we're going to get this, say get, and we're going to put another branch in here. Now, and plug this in. If the trigger is active, then go ahead and bring the plate down. If the trigger is not active, then we don't want it to do anything. And originally, we want to make sure that the trigger is active. Now you can choose to use a function to activate or deactivate this trigger based on different functionality, but we're going to set this to default active. And also, once we identify that it is the player who has stepped on it, we want to go and disable the trigger before we do all of these move function. So we're going to go ahead and get the trigger and we're going to say set, and off of the true, we're going to plug this in and say trigger is no longer active. Leave this empty. And when we reset the plate, we want to, after we set the position of the plating, we want to now activate the trigger again. We want to set and activate trigger. So that is the reset function. Every time the player steps on the plate, we want to register which plate number the player actually stepped on so we can create an array with it so we can check against our correct puzzle. To do that, first let's go ahead and delete this update plates. We want to create some sort of a manager who can actually manage this. So we're going to create a puzzle manager. To do that, I'm going to right click in the puzzles folder, click on blueprint class and create a new actor. And we're going to name this actor BP underscore puzzle manager. Now you can use this manager to manage all of your puzzles that you have in the game. I'm going to go ahead and save all of it, create a new custom event, register plate pressed. Here, when the plate get registered, we want to send in a functionality to this puzzle manager and say register the plate. And we don't want to cast it to the puzzle manager, so we want to use our interface to do the communication. I'm going to create a new function and I'm going to call this register plate. And in here, we want to give it an input. We want to give it which plate ID we want to register. So I'm going to give it an input name plate ID and name this integer. And go back to our puzzle plate and we want to say get actor of class because we want to get the proper class that we're calling this function towards, this interface function. That would be our manager, our puzzle manager, BP puzzle manager. And based off of this reference, we want to call in the message to register the plate and make sure it's a message. Grab the plate ID and we're going to plug it in here. This register function does not exist on the actual manager, so we're going to go and create that. So let's go ahead into our manager and we're going to create the register function. This manager, we want to go to our class settings first and we want to do the interface and add interface and then add the dungeon manager. Now you have the register plate function, so you can right click and then say implement event. Off of this register plate function, we want to take this plate ID and start collecting it. To collect the plate ID, I'm going to go ahead and create a new variable called player order and make this into a type integer. And over here, I'll make this into an array so it can hold multiple items. I'm going to take this player order array and I'm going to also say append. So it will add to the array. And then I'm going to drag off of this and this plate, I can just drag and it will automatically create a make array. So it will take this integer and then add it into an array and then add it back into the append. So every time the player steps on the plate, we want to now call in this register plate pressed. So up here, after we set the player plate location, we want to drag off of this and say register, not the message, register plate pressed. And this would be our function that is right here, register plate pressed. Once we register it, we want to check to see if all the plates have been pressed. So we can create a new function to do that. So I'm going to create and say check all plates pressed. Every time we register the plate, we want to check to see if all the plate has been pressed. So in this function, to check all plate pressed, we want to get our player order and we want to check it against all the plates that's in the game. Right now, we don't know how many plates are in the game. We are manually input all of it. So we want to create a function to manage that. So let's create a new function and say get all plates. Inside of this function, I'm going to say get actor, get all actors of class, and then select the puzzle plate and then make that as your class reference. And I'm going to say for each loop, for each of these actors that is in the game, we want to get their plate ID and we want to build a bucket. We don't want to just return it back. We want to create a bucket. So let's create a new variable and say all plate ID in game. All plate ID in game. And I'm going to drag this all plate ID in game and I'm going to say add and drag this plate ID into this. And we don't want to call this function every time the player steps on the plate because every time the player steps on the plate is when we're going to check if all the plates are pressed. We want to just call this once when the game starts because there's no point of calling it multiple times. So off of our event begin play, we don't need all of this. I'm going to say get all plates. This will initialize our all plates in game. So let me make that plural. Now let's go back to our check all plates. And now we have a new function with the bucket. that has all the plates in the game. So we're going to say get, and we're going to check if the player has stepped on all the plates that's available in the game. This is what we're going to check. To do that, we're going to get the length of the player order. We're also going to get the length of the all plates in game or plates ID in game. And we're going to compare and see if this length equals to the all player. And based on this, we're going to do a branch. So I'm going to select all of this, move it down. And then if it is true, that means the player has stepped on all the plates. If it is not true, that means the player has not yet stepped on all the plates. So off of false, we don't want to do anything. Off of true, if they have stepped on all the plates, we want to do a check to see if they stepped on the correct plate in the correct order. But we haven't really generated an order yet. We need to generate an order when the game starts so that when the player steps on it, we check against that order. So we're going to generate a random order. We can again utilize a function to do that. We're going to say generate random order. In this generate random order function, all we have to do is get all the plates in game, right? And then we're going to do a shuffle. So it shuffles it around, so it's no longer in order. And we're going to need a new variable to hold this new shuffled numbers. So I'm going to say correct order. And I'm going to get this. And we're going to append. And what we're going to append is we're going to append this new all plates. So now what this will do is it will take the all plates in game ID, the IDs of all the plates, shuffle it into random order, and then add it to this correct order as the one that we're expecting for the player to step in that specific order. Now, again, we want to call this only once because every time the player fails, you don't want to call it because that would just make it impossible to finish. So we want to just call this once. So when the game starts, it will get all the plate ID and then generate that random order for us. So we have something to check against. Once we check all the plates, we want to now create a function to make sure that the player's step order and the correct order is the same. To do that, we're going to say get check order. This check order function is going to be pretty straightforward. We're going to take a for loop, just a for loop, and we're going to get our all plates in game and get a length. I'm doing this function this way because I know there's only 4 plates in the game. I can easily add 3 here and then, call it a day with the function. But I want to have this function to be able to expand on its own. So if you add a 5th plate, I don't want this function to fail just because you added a 5th plate. So this is why we're going to get all the plates ID in the game. And then we're going to set our last index of our for loop based on how many plates are in the game. And for here, we want to always subtract it by 1. And this would be our last index. We want to check this order to see if the plate order and the correct order is the same, if every single one of them is same. And if it is not, we want to break it. Now, we can use a function called for loop with break, but I'm not really a fan of that function. I want to use a Boolean to check it. Create a Boolean, create a new variable and name it puzzle failed and question mark. And make this into a Boolean type, into a single Boolean. And original value, we want to set this to false. So that means the puzzle has not failed when the game starts, right? So we want to get this puzzle failed and then get a branch off of this and say, okay, when we loop each and every single time through this index, we want to check to see if the puzzle has failed. If it has failed, don't do anything. If it has not failed, then we want to check our correct order and our plate order. So I'm going to get our plate order and also our correct order, drag off of the plate order, and I'm going to say get a copy. Same thing for the correct order. I'm going to say get a copy. Now I want to check if these two are the same at this index, which is going to go through 1, 2, 3, and so on, as many plates that you have. So I'm going to drag this index and connect it into this get. So every time the loop runs, it's going to check one at a time. And again, we want to see if the plate order equals, and plug this into this branch. And if the puzzle has not failed, we want to check. If the puzzle is failed, we don't want to check. We want to stop this function right here. And if the player order is not the correct order, then we want to take our puzzle failed and we're going to say set puzzle failed. That's it. What this will do is this will complete the loop. When the function completes, we want to run a finish or reset functionality. So for that, I'm going to create a new integer and name this correct register. Correctly registered. Correctly registered. And I'm going to name this of a type integer and take this and get correctly in registered and then increment it by 1. So every time the loop runs through each and every single of these player order and correct order, it's going to run through 4 times because we have 4 plates. We want to increment this by 1 every single time. So at the end, if this correctly registered equals to the total number of our plates in the game, then we want to pass. If it doesn't, we want to fail. Now, our correctly registered starts at 0. However, this loop function also starts at 0. That means the first loop that it goes, and if it says pass, our correctly registered is going to be at 1, while our loop is still at 0. So we're always going to be 1 ahead, and at the end when we do our success fail check, it's not going to equal the same. To fix that, it's pretty straightforward. Click on the correctly registered and make this into a -1. Now what we want to do is we want to do the success and the failure. So first we're going to get our correctly registered, and we're going to check if this number equals to the all plates in the game -1 and do a branch. We're going to create 2 functions off of this true and false. First function will be puzzle passed. What happens when the puzzle passed? And also second one would be puzzle failed. Off of this puzzle passed, just for the purpose of the tutorial, we're going to say open door in a print string to indicate that the puzzle has been successfully completed and we can now open the door. Off of puzzle failed, we're going to say puzzle failed. And we want to do a couple things. First, we want to take our puzzle failed, and then we want to set this to false now. So it's no longer failed. After we fail the puzzle, we want to reset this, and then also get our correctly registered. And we want to set this back to -1 because it would have been incremented. So now we want to set this to -1. And you can do many different functions here. And also in the puzzle past, you can actually make it so that the door opens or the chest opens, whichever option that you're looking for. But I'm going to leave it this as it is and leave it to your imagination. And here, and if this correctly registered is equal to the number of all the plates, that means the player has done a good job. Then we're going to say puzzle has passed. And if not, we're going to say the puzzle has failed. After this puzzle failed, we want to clear all of our player order. So resets all of the player inputs to 0. So here we're going to go ahead and say get our player order, and we're going to clear. And at the same time, when the puzzle actually fails, we want to bring the plates back up so the player can step on the plate again. So drag off of this and say get all actor of class. And this would be of type our puzzle plates. And for each of the plate that's in the game, we want to now call in the function called reset plate loop body. This will reset the plate as well. Now, where we are checking our plates, we're ready to connect the functionality. If the player order size equals to the total amount of plates that are in the game, then we want to go ahead and see if we can check the order. So let's plug this into the true. If it is not, don't do anything, right? One last function before testing that you want to do is to drag and drop the puzzle manager, into the game. All right, now if we press play, you'll notice that the correct order is 0, 2, 1, 3. If I close it and play again, the order has changed to 0, 1, 2, 3, 3, 1, 2, 0. So you see that it's actually randomized every single time. And right now the code is 1302. And if I give it a wrong code, so that'll be 0, 1, 2, and 3, you'll notice that it'll say puzzle failed and all the plates are back up. And if I do it again, 0, 1, 2, 3, you notice it still fails and the puzzle's back again. Now, if I do the correct order, I'll say 1, 3, 0, and then 2. I'll say success, open door, and plates will stay down as completed. Now, if I go in game, I don't really know what the correct order is because it doesn't really state what the correct order is. So one easy way for me to check is to go to my viewport add a text render, right? And then call this correct order. Oh, correct order. Okay. Call this correct order with the colon. Okay. Compile. Save. Take this. Okay, that looks good. And I'm going to go to the function where we generate the random order. Off of here, I'm going to get my correct order, set text, format this text, type in correct order, colon, and I'm going to put these little parentheses 4 times. And inside of these parentheses, I'm going to go 0, 1, 2, and 3. This will give me 4 options here, so I can get the 4 different numbers that comes out of this, and then set the text to that. How do you do that? You grab the correct order, get a copy of it, and then 0, you're going to plug it into 0. And then copy again this, paste it, plug this into 1, and make this into 1, and so on. Thank you again for coming this far. I'll catch you again on the next Dungeon Mechanics tutorial series. Thank you.